Hi guys, this is Dan. Welcome to my YouTube channel danjunk-DIY. In today's do it yourself project, I will show you how to restore a USB camera retrieved from a battered, broken Lenovo laptop. I found this laptop in a junk dealer's shop. He's a friend of mine and he offered me to take it and extract any useful items which may be used for my project. Okay, well, this is a Lenovo laptop, badly damaged, broken. Somebody has thrown it out, and so it is all in a broken condition. So I intend to retrieve the USB camera or the web camera, built-in camera in this one, and try to restore it. Okay, so here we go. Things is badly damaged. This is the RAM. I think this is the processor fan, cooling fan. We are not interested in this. Let me take out this. So keyboard. We'll discard this one also. This is the screen. The camera should be somewhere here. Yes, here, this is the camera. This is the USB camera. Yeah, here it is. So this is the USB camera. Hopefully this is in a working condition. So let us identify the wires, connections, and try to restore it. So it is a well-known fact that these are all digital circuits. They work on 5 volt or 3.3 volts. Okay, low power devices. So our objective is to identify the right wires through which we feed the desired power input, that is the 5 volt input. Okay, right, so let us work on it. So my first objective is to identify each wire and establish which is the positive terminal and which is the negative terminal and which is the data terminal, right? This is the camera lens. This seems to be some sort of processing circuits. Well, let us work on this, and first let us tidy up this place. We don't need these things. Let it be here. So here is our USB camera. So before we proceed, it is necessary to make out a layout of the wires and the connections to understand them logically. Okay, just take a paper. Well, let this block represent my USB camera. Okay, now here we have a lens over the camera portion, the pinhole here. These are components here and components this side, and here we have a connector. This connector will represent I think there are 5 wires jetting out of this connector, so I'll just note it down what is what. Number 1, 2, 3, 4 and 5. So here comes the first one, and what is this one? This is an yellow wire. Okay, this is yellow and orange, red and brown, right? This is an yellow wire. This is orange. This is red. Okay, you can have a look once again. Red and brown. Okay, it is clearly visible, red and brown, then black. So, logically speaking, this device must have a positive terminal and a negative terminal from which the power is fed by the PC to activate this camera, and there has to be a data output terminal. Okay, now we have 1, 2, 3, 4, 5 wires. So logically, any USB device should have 3, 4, 1, 2, 3, 4, 4 connections. This is a USB connector, standard representation. So normally the extreme terminals are positive and negative. It may be the either way also. Okay, and the center terminals are data terminals, data plus and data minus, right? This is the standard circuitry. So there has to be some mechanism where these wires gets connected to this sort of input, right? Now our intention is to identify which is positive, negative, and well, to summarize the concept of working of this USB camera, we have understood the wiring connections here, and we logically think that this twisted pair is a data line, and one of these black, yellow, orange are the power lines. We should have one positive, one negative, but we have an extra wire also that we will do it, find out what is it, and ultimately internally it has to be linked to the internal USB connections like this internally, and to power up this camera and activate this functioning of this camera through the software. Okay, so this is an illustration of USB connections. Internally also it should be the same. And now let us localize, which is find out which is the positive and negative terminal, right? So for that we need a multimeter in a continuity mode, and I'll just tin these terminals. Okay, to expose the copper. Okay, this is the data line. Okay, I'll bit untwist this one to have a good access. Right, here it is. So now let us work on these three terminals, remaining terminals, to understand what is what. Okay, and another thing which should understand while we are working on a printed circuit board is the backside portion, which is shining. This is a copper or some sort of gold plated thing also. It may be in computers, many of these connection points are gold plated. So I have scratched this a bit here, right, to expose the copper or the metal. This is now the ground plane of the circuit board. The ground plane is probably in most circuits it's a negative terminal, which is a reference for all voltage levels for the various components on this circuit, right? So I will take one of these terminals. Let us start with orange or yellow in a correct order as we have seen from the connector, and check it with the ground. Yes, it is showing a zero resistance, so this has to be the negative in all probability. Then we'll go to the orange. This here is our orange, and here is the ground. Yeah, here also it is showing zero resistance. That means yellow and orange both are interconnected to the circuitry. For the reasons which I am not clear, they have given two wires externally, maybe for some other logical switching or whatever the intention may be. Let us not bother about it. Technically speaking, yellow and orange both are connected to the ground. Well, having identified yellow and orange as negative terminal, let us proceed to check the remaining wire. That is black, the black wire. It is the last in the order. We have done yellow, orange, red and brown being twisted. We logically understand it must be the data line, and we go to the black. So let us go to the black, put one prod of with this one and check with the ground. If it is yeah, it is about 1.4K. It is about 1.4K, and I will just reverse the prods and check it. It's about 575 ohms. So this has to be a positive terminal, right? Had there been any electrolytic sort of capacitor, something like that, I could have identified it. But logically speaking, since we have the ground point and this has to be the positive one, so let us see. Okay. And one more measurement we'll make. We will check the resistance levels. I will write it down here once again. The same replica, I am writing it down here. This is orange, sorry, yellow, orange, data, and this is black, right? Now with reference to ground, we will combine these two. We will check the data level. Logical status of the data level. It is showing infinity. Okay, this is infinite. Both the terminals are having infinite resistance. Okay, with reference to ground, right? This is ground, negative. Between this one and this one, this is infinity, and between this one and this connection also there is an infinite resistance. That means these two terminals are open. You can call it open. Okay, right? So this being the input device, the input impedance is very high in this one. Okay, so they are open now, right? So this will be terminated with the USB, where the pull-up resistors will be on the USB side, right? So then it will go either high or low, right? The logic states will go either high or low. Now let us see with reference to positive terminal, what is the status of the data? That is also infinite. That is also infinite, right? That means the inputs are open-ended. Only when it gets terminated with the USB, then they attain some logic levels, right? Let us proceed further. Now our next phase is to interface with this proper connector. Well, this is my USB cable. Okay, and the other one is operated. I'll peel off a little of wire here. This much is sufficient. So this USB is having a different color code altogether. This may vary from connector to connector. See, I have red, yellow, black and green. So here also we have to identify the format pin out of this pin configuration of this USB, right? So by convention, red may be positive, black may be negative, and yellow and green may be the data connectivity, right? In USB there are 4 pins. So now to find out which one is positive or negative, straight away we will connect it to the PC and see the voltage between these points, right? Let us see which is. In my opinion, this data lines also should be at the positive voltage level, right? So let us switch on our PC and identify the power levels on these lines, right? Voltage levels rather on these lines. Well, this is my PC. This is my laptop, Dell laptop. So let me check the voltage levels on these lines. So I booted my Dell laptop. Okay, so before that, I have to expose this. So carefully I have stripped it out. I'll tin each terminal so that I should have a good contact when I make voltage measurements. That should be okay. Now I will put it here to the USB. I have connected this USB plug into the terminal USB port. Now this is live. Let me check the voltage levels here. Let us assume black could be the negative as per convention. So here I get 5.2 volt, right? And reverse the polarity of this my prods. It is minus 5 volts here, right? With reference to this one, that means this is positive. Okay. Now let us check this one. 0 and 0. With reference to ground, these both are 0. Doesn't mean that they are short circuited. The voltage levels are 0. With reference to positive, it is at minus 5 and it is minus 5, right? So these must be the data lines. With reference to positive, I am getting, that means this is 5 volt and this is 5 volt. These are the logic levels, right? Now between this data, one of the data lines, and ground, I am having 0, minus 0, right? That means this is a logical state. This is at a logical state, these two, right? So these are my supply points, positive, negative. Alright, having done this, we have to interface this camera with appropriate terminals, okay, magic terminals, and see whether this camera switches on or not, right? So for this, first I will take out this power, right? Now PC is not required for the time being, let it be here. to make some arrangements. First I need a connector. Yes, I have created interface. I have to create an interface. Well, I have created an interface for this USB. Okay, this side it's going to the USB connector plug, and this side I have to interface the camera. Okay, I have connected this in this order. Plus red is positive coming out of PC, green and yellow are data lines, and black one is negative terminal on the PC, right? So I get 5 volt between extreme points, and the center 2 points are data, right? Now the color coding from the camera side is entirely different, so we should not get confused. Here the orange and yellow are connected to the ground of this camera, that is the negative terminal of this camera. Black, as per my logical assessment, is the positive one, and the twisted pair of red and brown is the data terminal. Data plus and data minus of the USB. So first let me club this ground point, that is the negative point. Okay, now where is my negative? The top one is negative. I will tin each terminal so that I'll be able to solder it easily. This is my negative terminal. Yes, negative is in place. Here I should not mistake black as negative. Here the black is negative this side, PC side. Okay, now one of the data terminal I am connecting it here, but I do not know which is data plus and data minus. Arbitrarily I am connecting it. But my power should be proper. Power connection. Data may not be. If it is not connected, it may not detect at all. But power should be proper. I can interchange the data connections. So here my assembly is ready. Right, this positive of the camera, twisted pairs are in the center, and yellow and orange are negative, going to the negative of this. Right, if this connection is okay, my PC should detect the camera and I should get a picture when I run the camera app. Well, this is our complete setup. This is my restored USB camera, illustration of the wiring diagram. This is my USB connector. Now let me connect it to the PC and see whether this camera gets detected. Okay, I'll Yes, I'm connecting it. You heard the sound, the camera is detected. As such, there are no indicators on this camera to indicate that it is powered up. Now let us check it on the PC. This is my test PC, Windows 10. I'll run the camera app. So initially it may show, here is our camera. Okay, yes, this camera is active by default. The internal camera is triggered, right? This is the internal camera now. So we have an option of switching this to this external camera. I will bring the mouse here. Here we go. Yes, there is some activity on the screen. Now this is my camera, this is active. You can see I'm holding this, and the side screen also you can watch it. Okay, I'm tilting the camera, right? This is my test setup here, extension board, multimeter, tools, my drawing, illustration of this diagram. You can see it on the screen. Just I will pan it across the room. There's my Bluetooth speaker alongside the PC. Alright. I'm rotating the camera and you can see the movement of the image on the PC screen. Well, our camera is working. Right. I'll put it down here now. Okay, hope you enjoyed the project. Watching the project. If you like it, please give me a thumbs up. And I'm planning to use this camera for surveillance purposes around my house. I will consider it in a proper enclosure so that I can use it as a CCTV configuration. In a CCTV configuration, I will use it as a surveillance camera. So thanks for the junk dealer who has given me this piece. Okay, like this we may do so many things. So keep watching my channel danjunk-DIY. So let's make something new in my next project. Please join me and keep watching my channel. Give me a thumbs up please. Thank you very much. Thank you for watching. Bye.